All right, stats class, here we go. So we're learning ANOVA. Okay, sounds all right. That can't be too hard. Oh, ANOVA stands for Analysis of Variance, so that's a little less cool sounding, but whatever. Should still be easy enough to figure out. So he's talking about interratio level variables. I know what those are. ANOVA is used when we want to compare samples of more than two dependent variables. Makes sense. Wait, did he say between groups and within groups? What groups? Two separate estimates about population variance? Why two estimates? What's an SST? Or did he say SSB? Did he say both? Now there's an SSW? How are we expected to understand this? It's impossible. Only a stats nerd could figure this out.
We can help you after class if you want.
Sure. I guess that would work.
Shortly after class, Tegan and the nerds took over a classroom in MDCL, and they were there to teach her how to use and understand ANOVA! Yeah! The nerds were really excited to show the confused student how to use all the variables and the formulas to finally understand ANOVA and maybe pass stats.
So how do you guys know all this anyways?
Well, we go to class all the time and we read ahead.
But does going to class honestly help all that much?
Well, coincidentally, I found this sheet of paper in the poli-sci department, and it's got everybody's marks based off of how often they went to class.
And since there's 3 groups in the sample, students who go to all the classes, students who go to half the classes, and students who don't go at all, it's going to work perfectly for our demonstration. So you'd want the hypothesis to be that there's significant difference in student performance based on the number of classes they attend.
And our null hypothesis is that students who attended all the classes, half the classes, and none of the classes do not vary in their test scores. That's the same as writing U1 equals U2, which equals U3.
To find out if there's a difference, we cannot just look at means. We have to consider the means of scores with respect to their standard deviations. Remember, standard deviations represent how far apart scores are in individual categories.
So we have to look at how far apart the means are between categories, as well as how far the grades are within each category.
Yeah, but we'll be looking at variance instead of standard deviation, which is just standard deviation squared. That's how we get SST, SSB, and SSW. SST is the total sum of squares, SSB is the sum of squares between, and SSW is the sum of squares within.
So now we'll need to input all of our information into our formulas. Before we go on to the formulas, let me explain what each variable represents. X is an individual case. In our situation, it's the grades of the students collected in the samples. N is the total number of cases, 18. X bar is the mean grade among all of the categories. NK is the number of cases in a particular category. XK is the particular case of one category.
Now we'll need to input the information into our new formulas.
The first formula is SST equals SSB plus SSW. SST also equals the sum of x squared minus m times x bar squared. SSB equals the sum of nk multiplied by x bar k minus x bar squared. SSW can also be rearranged to solve equals SST minus SSB.
So let's first calculate SST. Using the formula we just said and plugging in the numbers from our chart, the final answer we get is 6,387.92. Using the SSB formula, we'll find that the variance between groups is 4,915.64.
Now we need to find SSW, which is the variance between groups. To do this, we'll rearrange our very first formula for SST. When we do this, we'll replace in all the numbers that we just calculated. When we do so, we find that SSW equals 1,472.28.
Now we have to calculate the degrees of freedom using 2 simple equations.
For the DFB, subtract 1 from the number of categories K.
So now we have to find the mean square estimates. But remember, there will be two of them. One for the mean square between the groups and one for the mean square within groups. To find this data, we'll use the numbers we've already calculated, SSB and SSW, as well as the degrees of freedom, DFB and DFW.
0.82 respectively.
Now we just need to find our F ratio, which is the same as our F obtained. To find this, we use the equation mean square between over mean square within.
When we do that calculation, we get an F obtained of 25.04.
Now we need to compare our F obtained with an F critical. To find F critical, we need to go into Appendix D of our textbook. We need to use our degrees of freedom, DFW and DFB, to find our F critical, but first we must choose an alpha level. For the sake of this presentation, we're going to choose an alpha level of 0.05. Now we follow our DFW of 15 to the DFB of 2, and we find that our critical level is 3.68.
So our F obtained is greater than our F critical. This means we can reject our null hypothesis that students who go to all classes, students who go to half the classes, and students who don't go at all get the same marks.
This means that our research hypothesis was correct. Depending on how often you go to class, you will not be getting the same grades.
Yay! I finally get it! Thanks, guys.
Now we'll use SPSS to conduct a one-way ANOVA test studying the significance difference in average monthly rent payments by province. We're going to start by collapsing our smaller provinces into groups or regions to create more equal sample sizes. We're going to use the SPSS recode command and collapse the PR provinces into 6 regions. Code, we're going to select ranges of responses as well as individual responses and give them a new number. Of course, 10, 11, 12, and 13, Newfoundland, PEI, Nova Scotia, New Brunswick will become 1. 24, Quebec will be given 2. 35, Ontario will be given 3. 46 through 47, which is Manitoba and Saskatchewan, will become 4. 48, Alberta will become 5. 59, British Columbia on PR into a score of 6 on region. Continue, you will find yourself back at the Recode into Different Variables dialog box. Click OK and SPSS will execute the transformation. Then we want to continue on and conduct the one-way ANOVA test. To do so, we need to input the variables into the boxes. First, you need to pick the gross rent, and then second, you pick region. Then you click descriptive because we want to make sure that we have descriptive data. And SPSS has done the work. Here's the one-way ANOVA test results. That rent is distributed differently across regions. The difference in mean rent between the regions is statistically different. As such, we reject the null hypothesis. Yay!